All right, let's go ahead and try solving this right triangle. First things you want to do, obviously, let's identify all of the missing side lengths and all of the missing angle measurements. First things first, what's missing over here? We need to find out what G is, we need to find out what H is, and we want to find out what this missing angle measurement is. So the measure of angle G. All right. We can approach this many different ways. I'm going to think about what works best for me. You might want to try something different. As long as you arrive at the same conclusion, it'd be good to go. All right, let's start off with, I think the easiest thing to do here is actually going to be finding out the measure of angle G. Since we already know 25 and 90 degrees, so the measure of angle G is going to be equal to 180 degrees minus 90 degrees minus 25 degrees. If you don't want to do that in your head, feel free to use a calculator. But 180 minus 90 is 90, and then 90 minus 25 is 65 degrees. So the measure of angle G is going to be 65 degrees. That was easy. We're already 1/3 of the way done. Okay, well, since we know that that is there, I'm just gonna put this, I'm just gonna fill this in as well. So this is 65 degrees. Okay. Now that we have our angles, we can go ahead and find out our side lengths over here. Let's try to find out the side length of G, okay? So let's start off with G. Okay, so we notice that G is located here, and I see that if I wanted to use a trigonometric ratio, what side length is available to us? We have the 13 here, and since we already know that we have a hypotenuse, we do not want to use tangent in any way because tangent requires us to have opposite side and adjacent side. Since we don't have both of them, we only need one thing, right? Since we don't have any of those, we're not going to use tangent here. So you can use either sine or cosine to solve for this one. I'm going to use, let's use cosine this time around, okay? So in order for us to find the side length, let's keep it green. Let's use the cosine. So the cosine of angle, let's use H actually. The cosine is going to be our adjacent over the hypotenuse. So the cosine of H is the adjacent. Oh, well, the adjacent side of angle H is G. Cool. So that's what we want. So G over the hypotenuse, and the hypotenuse is 13. What else do we know about H? Well, we already know that the measure of angle H is 25 degrees. So now I'm just going to substitute that value. So the cosine of 25 degrees is going to equal G over 13. And now we just want to isolate the variable here. What are we going to do to both sides? We're going to multiply 13 to both sides. So now what do we have? 13 cosine 25 degrees. Oh, I hate that so much. Sorry. 13 times the cosine of 25 degrees is going to give us G. All right, let's go ahead and pop this into a calculator and see what we get. 13 cosine 25. 11.78. What does it say? To the nearest tenth. Okay, so G going to approximate to 11.78. If it is 7/8, we're going to round it to the nearest tenth. That is 11.8. Very nice. All right, last one. Let's go ahead and find H now. So side length. Focus here is H, little h, lowercase h. I'm going to use blue for this one. Okay. If you wanted to use cosine, then remember that h has to be your adjacent. But for this purpose, let's try out sine actually, okay? So the sine is going to be our opposite over hypotenuse. So what is the side that is opposite of h, or of this big H? Small h. See, it's opposite. So the sine of h is going to be little h over the hypotenuse, which is 13. So now let's substitute these values again. So the sine of 25 degrees is going to equal h over 13. Okay, so just isolate the variable h now. So 13 times sine of 25 degrees is going to equal h. 13, 9, 35. 7.456. H is going to approximate to the nearest tenth. 7.45. 7.45. Remember, round up. 7.5. And we have solved all missing measurement angles and side lengths. Okay, that's it. Bye.